All right, welcome back, everybody. Today we're taking a look at rational numbers. This diagram is a good representation of what rational numbers are. Rational numbers um, can be any anything written either as a fraction or a decimal, where if our denominator, the only rule is that it cannot be equal to zero, would be a rational number. So whether if it's a whole number, a decimal, a fraction, falls into a rational number. So it's kind of like a inclusion of all of these things. It can be natural, whole, integers, and then anything outside there. Um, so first off, how to graph rational numbers. So with these, we want to kind of see where they are in relation to zero. So if I take a look at 2.25, well, I have this would be, 1, 2. And if I understand 2.25, I have about halfway between 2 and 3 is there. So my 2.25 has to be right about there. So about 2.25 is going to go right there. Now on to 1 and 3/4. Well, 1 or negative 1 and 3/4. 1 and 3/4 is closer to a whole, and 1, negative 1 would be there. 1 and 3/4 would be about there because it's closer to negative 2. So about there would be negative 1 and 3/4. And then obviously 0 would be right on 0. So um, with these, all we're doing is looking whether if it's positive, we're looking 0 and up. If it's negative, we're looking to the left, and we are, um, plotting them on a number line. I've got another example here, so if you want to, um, try it on your own, pause the video, try it out, see what where you come up with. So, moving on, now what we're trying to look for is absolute value. So remember, this is the total distance from zero. And remember, absolute value will always be positive. So kind of a refresh from the previous lesson. Um, Go ahead and click the video if you want to, or pause the video so you can practice these on your own. Um, so starting off, if we have negative 2.5, the absolute value would be 2.5. And it's just the total distance it is away from zero. If we have negative 53 and 4/10, the absolute value would be 53 and 4/10. Everything's positive. If the uh, absolute value of 25, it's just going to be 25 because it's always a positive number. So that is something that we want to be, continually practicing. So um, moving on now, when we are comparing rational numbers, there's a couple of things that we need to look for. One, do they have different signs or similar signs? So if they have different signs, and whatever is positive will automatically be greater than the negative. So in this case, we would have 1.5 is greater than negative 1.2. If we want to visually show that, we can plot it right there. Well, 1.5 is right about there, so that would be 1.5 or 1.5. Negative 1.2, negative 1 is right there, and 0.2 is like right about there. So we would have negative 1.2 or negative 1 and 2/10. So this, we know it is greater than this guy, so we know that's the case. If we have same signs, whether if they're both positive or both negative, this is where we need to, see, which one's greater. Positives are a lot easier because which one is further away from zero. Um, but with these, I wanted to do an example of both negative numbers. So if I zoom in a little bit, negative 1.5 is right about there. Negative 1.5. And then 1.2 would be right about there. And I'll draw a little thing, negative 1.2. So in this case, negative 1.2 is closer to zero. So by default, this one will be greater. So if I rewrite this, whoops, negative 1.5 is less than negative 1.2. If we want to bring this down, and if we have um, a decimal and a fraction, what we want to do is make sure we're playing on the same playing field. So ideally, we would want to either convert these to decimals or both decimals or both fractions. In this case, I want to shift these to fractions. And so with this one, I know I have 51 hundredths because I look at the final decimal point, and I have 51 hundredths. So I take this, I put it over 100. And so here, I would have to multiply both terms by 4. So I am now comparing negative 51 hundredths to negative 100, and 12 times 4 is negative 48. So now I have to go back into my number line system, and if I have, let's say, 0, and then I'm going to go to negative 1. So negative 0.25, negative 0.5, and negative 0.75. Well, I got negative 0.51, and that is right about where this guy is. But I have to remember my original, negative 0.51 is right about there. And then my negative 48 hundredths, well, that's just before, and we're talking very, very small numbers. But this one, instead of writing it as this, I want to write it as the original, which was negative 12/25. And so we can solve our, I think this guy is much closer, or it's closer to 0, not much closer, it's closer. And so this is going to be less than if we converted it to fractions, but we want to answer it in the original form. All right, so that same tip is going to carry on all throughout these, whether if we're ordering or comparing. What we want to do when we're ordering rational numbers is to make sure we're writing in the same form. Preferably, we would want to convert to decimals because it's a little bit easier to make sure everything is using the same denominator. Um, we can use fractions, but most of the time it's a little bit easier to look at decimals. And then 2, we want to be using signs, place values on a number line to compare, and then from there ordering from least to greatest, greatest to least, depending on what they are asking us to do in the problem. So I have one example here that I went ahead and did. And we can see I had to convert everything to decimals. So I know that 1/4 benchmark decimal 0.25. And then to go from negative 17/50, what I did, I multiplied both my numerator and denominator by 2, and I get negative 0.69, or I would get negative 69 hundredths. And then I would just leave the other decimals as they are. And then from there, I can plot I plot in order. And then from there, if I wanted to go least to greatest, I could, or if I want to go greatest to least, I could, because everything visually lines up. And this also helps when we get into, kind of crazy decimals like that, or trying to measure decimal fractions like that. These guys are very, very, very close to each other. So sometimes writing things on a number line visually gives us an understanding. Oh, okay, that's either farther from 0 or closer to 0, or whether if it's positive, negative. It gives us a better understanding in a visual aspect to see where these guys are. The final example that I wanted to go over, if we have mixed numbers, we want to convert these to decimals. If they're already in decimal form, great, we leave it alone. So with these, first, I want to convert these to 100. So 25 times 4 gets me 100. So I would have 2 and, uh, sorry, 88 hundredths. And that's how I convert that to this decimal. I just put 2 and 88 hundredths to an 88 hundredths. Same thing here. 10 times 10 gets me 100. So I would just have 2 and 1/10 down below. And then from here, I can sort everything out correctly. And that is pretty much it for rational numbers. If you, uh, video find this useful, give it a thumbs up, and I will see you in the next one. Take care.